All right, in this lesson, we are going to talk about the different number of ways to arrange things. So, in order to do this, there are two formulas that you're going to need. One is called a permutation and one is called a combination. The good news is that if you have a graphing calculator at home, I'm going to show you how to use your TI 84, 83, whatever you have. If not, I'll post a website for you guys to use that you can do it with, or you could always do it by hand, but it's really up to you. So a permutation is going to happen when the order matters. Okay, and you'll see down here some examples. So what's the probability, or how many different lot combinations are you able to make? How many different ways can you select these 5 positions from a club of 24 people? Because the order will matter there. You're assigning everybody a role. Okay, just like in a lock combination, 1, 2, 3 is different than 3, 2, 1. Only one of these is going to open the lock. So that's really what we're trying to figure out. And you need to use factorials, but there is a formula that goes with it. So this is the formula. It's n factorial. And then the P is showing you that it's a permutation over n minus r factorial. So essentially, here's what it means. If I had, for example, let's say this one. In a group of 24 members, how many ways can I pick these 5 positions? And so you would essentially read this as saying that you have 24 people and you're going to organize 5 of them. So for example, I would read this 5 pick 3. So 5 pick 3 would mean that you have 5 things to pick from. Okay, you have 5 numbers to pick from. How many 3-digit combinations can you make? And 3-digit combinations have to be unique. Okay, so I would do 5 factorial over 5 minus 3 factorial. 5 minus 3 is 2 factorial, and that's why we did this last week. This would be 5 times 4, 3, 2, 1, over 2 times 1, boom, boom. And you would see that there are 60 different combinations of 3-digit numbers if you had 5 to pick from. So that's not the numbers 1, 2, 3. That's not saying how many ways can you arrange these numbers. It's saying you have the numbers 1, 2, 3, 4, 5. How many different combinations that are unique can you make? And you can write 60 different combinations of 1, 2, 3, 3, 4, 1, 2, 4, 3. So you'd be here for a while listing all 60. Okay? 4 choose 4. It's going to be 4 factorial over 4 minus 4 factorial. 4 minus 4 is 0. Remember, 0 factorial is 1. And so then this is just 4 factorial, which is 4 times 3 times 2 times 1. Or, what was that, 12 times 2, 24. So there would be 24 different ways to do that. Okay, now you can do this in the graphing calculator. If you have a TI 84 at home, you're going to put in the calculator. So for example, the next one is 4, pick 1. So I'm going to put in 4, and then I'm going to go to stat. Nope. Second stat. Nope. Where is it? No. There we go. It's in math. It's in math, and then you have to go to the probability menu, which is that one. And then you're going to click number 2. So math, prob, and then for this one, it's going to be 2. Oh, you need to put 4. Okay, different calculators are different. So this one's going to be 4 use your little arrow key, and then 1. So it will be 4. Again, if you're doing it by hand, it would be 4 factorial over 4 minus 1 is 3 factorial, which would just leave you with 4. This one's going to be 8 factorial over 8 minus 5, which is 3 factorial. So again, if you don't have a calculator, you have to do it by hand. You do 8 times all of the numbers all the way down to 4, or using your calculator, math, 2, 8, 5. So you do 8, scroll over, and then 5. So 6,720. If you do not have a TI-84 or whatever at home, you can use another website. I'm going to put it up on the Google Classroom. It's called Desmos. It's essentially the same thing, only you're going to put it in parentheses. So here it is. So this is what it's going to look like. You're going to do function, and you'll see down here it says NPR. So you would click this. This is going to ask you, what is it, 12 pick 7. So you would put NPR, but it's going to ask you to make it, put it in parentheses. So it's a little bit different in the calculator. So 12, I went back to main to get the numbers. 12, comma, 7. The answer should be 3,991,680. If I do it on the TI, you don't need to go back to that menu every time. If you hit second entry, you'll get this, and then just change the numbers. 12, pick 7. So it's the same thing. 3,991,680. 3,991,680. So that is the formula for a permutation. Okay, when you're doing it in a word problem, usually it will tell you how many you have to pick from, and then you would just apply the formula. So a combination lock will open with the right choice of 3 numbers, and the numbers are going from 1 to 30. So you have the numbers 1 to 30 to pick from, which means you have 30 numbers. You're going to choose 3 of them, and you're going to assume that no number is repeated. We're going to do repetitions in a little while. So I have 30 numbers. Order matters, so I'm going to use a permutation. 3. So 30, pick 3. 30. Again, I'm just doing second enter on here. So it should be 24,360. So if you were trying to guess somebody's locker combination, you would have to try 24,360 different combinations. From a club of 24 members, so 24 is what you have to select from. You're going to choose 1, 2, 3, 4, 5. So this would be if you took a survey and you were trying to see how many votes each person got. That's why the order matters. So it's based on the order, or if you are assigning roles, which in this case you are. So again, 24 NPR 5. I'll use the other calculator real quick. So function NPR, go back to the main, 24 5. So there's 5 million different ways that this could happen. So 5,140, 5,100,480 different ways that you could select 5 people to be the president, vice president, blah, 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 blah. So there is that. Okay, and then I'm going to do this, and then I'm going to leave the rest of the notes for tomorrow. So let's just do permutations today. If you have a word or a time where something can repeat, you have to kind of do a different formula, okay? So for example, in the word Miami, if you just had the letters M-I-A-M-I and you wanted to rearrange them, you don't know if when you pick an I, is it the first I or the second I? Because those I's essentially have the same value. So because there are two I's, I have to take that into consideration. Sorry. If you are going to repeat letters, here is the formula. So how many letters total do you have to pick for Miami? Well, you have to pick 5 because there are 5 letters in Miami. And then you're going to divide by the number of times that a letter is repeated. So see how there's 2 I's? So you would do 2 factorial for those 2 I's, but you also have to do 2 factorial because there are 2 M's. Okay? It's really up to you how you want to do this. If you want to put it in the calculator, you can, or it might be easier just to simplify this. 2 factorial is 2. 2 factorial is 2. So this is 4. And then in the numerator, you would have 5 times 4 times 3 times 2 times 1 divided by 4. That 4 is from here. You could just cross out these 4s. 5 times 3 is 15 times 2 is 30. So it's going to become less, there's less combinations because you have numbers that are repeating or letters that are repeating. Okay, so for example, Virginia. In the word Virginia, you have the I repeating, and that's it. So in Virginia, there are 1, 2, 3, 4, 5, 6, 7, 8 letters. And there are 3 of the same letter. No other letters are repeating, so I don't need to do anything else. It's just 8 factorial over 3 factorial, which if you want to put this in the calculator, again, you can. It would be 8. You go to math, probability, hit the 4. That's going to give you your exclamation point, divided by 3. Exclamation point. So 6270. Let me see real quick on the other calculator. Yeah, it has it here. So you would do 8 factorial. You got to keep hitting the buttons, which is annoying, but 3 function factorial, and you get 6720. Same thing for Tallahassee. This one, you have a lot of letters that are repeating. So first count how many letters are in Tallahassee. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Over, it's going to seem like it's a big number, but it's not going to be because a lot of these letters can go into multiple places. The A can go into 1, 2, 3 positions. L's can go into 2 positions. H is unique, T is unique, S can go into 2 positions, and E can go into 2 positions. So I would just take care of the bottom first because it's a little messy. I would do 11 factorial over 3 factorial is just 3 times 2 times 1, so that's 6. This is 2, 2, 2, so times 2 times 2 times 2. Oh, what is that? 12 times 2 times 2, that's 48 times 2, that's 96. So whatever this is 11 factorial over 96. I'll use this calculator. So 11 factorial over, we had 96. So 415,800. So it's pretty easy. It's a little tedious with the calculator, and especially now that the calculator has to be on the computer. I guess a little bit more annoying. I'm going to leave these here. I will put these answers on Google Classroom. And then we will worry about doing the rest of this tomorrow. So honestly, for today, I just wanted you guys to watch this, check these answers. Actually, I'm going to put these in a Go formative. I lied. So after you're done watching this video, do these problems, and then you just have to do 5 questions that you have to answer in a Go formative. And then tomorrow we will do if the order does not matter.